warahmatullahi wabarakatuh. Inshallah, our group will present Chapter 5, Chemical Reaction, and I, FARAH BINTI ABDUL GHANI, will start off the presentation with Chemistry in Baking. As an introduction, baking might not seem like it involves chemistry, but the ingredients you use undergo chemical changes to form the final baked goods, mixing together the eggs, flour, sugar, water, and other ingredients to make dough. Then, baking that dough in an oven can seem like a simple but magical process. The delicious end result that appears accentuates the extraordinary nature. It's not magic, however, but a series of complex chemical reactions that is behind this cooking process. So this is some chemical reactions that occur when we bake. First off, we will start with protein bonding. Flour contains two important proteins, which are glutenin and also gliadin. When water is added to flour to make dough, it allows these proteins to bond together and form a new protein called gluten. Gliadin plus glutenin plus H2O will form disulfide bond, which then turns out become a gluten network. Kneading the dough intensifies these gluten bonds. After the dough is placed into a heated oven, it begins to rise and grow the gluten network. This network eventually hardens during the baking process, giving the inside of a loaf of bread or similar baked goods a signature structure. Next up is the magic leaveners. Some of the leavening agents are yeast, baking powder, and baking soda. These leavening agents give the baked dough its pillowy lightness. The first one is baking soda. Baking soda achieves the feels of pillowy lightness by reacting with acids in the dough to produce carbon dioxide gas, which puffs up the dough. Next, baking powder. Baking powder releases carbon dioxide twice during the entire baking process, which are once when it heats water and once when it reaches a certain temperature in the oven. Lastly, it is yeast. When yeast is added to the dough, it begins to feed on the starch, producing sugars, alcohol, and also carbon dioxide as the byproducts. As with baking powder and baking soda, the carbon dioxide produced by yeast causes the dough to rise. Next off is the Maillard reaction. Maillard reaction is a non-enzymatic browning. Maillard reaction occurs when proteins and sugars are broken down and rearranged by high temperatures. These sugars and proteins can be derived from flour by itself, or they can be enhanced with the addition of sugars and eggs. The reaction produces ring-shaped organic compounds that darken the surface of baking dough. Maillard reactions also produce toasty and savory aromas and flavor compounds. These compounds also react among each other, producing even more complex aromas and also flavors. Lastly, it is caramelization. Caramelization, which occurs at 356 degrees Fahrenheit, is the last chemical reaction to occur during the baking process. The reaction occurs when high heat causes sugar molecules to break down and release water, which turns into steam. Diacetyl, which gives caramel its butterscotch flavor, is produced during the first stage of caramelization. Next, esters and lactones, which have a room-like flavor, are produced. Finally, the production of furan molecules imparts a nutty flavor, and a molecule called maltol imparts a toasty flavor. So this is the caramelization process. And this is a caramelization versus Maillard reaction, the differences. Caramelization is an entirely different process from Maillard browning, though the results of the two processes are sometimes similar to the naked eyes and taste buds. Caramelization may sometimes cause browning in the same foods in which the Maillard reaction occurs, but the two processes are distinct. How? Basically, they are both promoted by heating, but the Maillard reactions involve amino acids, whereas caramelization is a pyrolysis of certain sugars. That's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, my name is NURHASHIMAH binti BAHRAIN. So today I would like to explain about chemical reaction in our daily life, which is chemical reaction in photosynthesis. What happened during photosynthesis? Alright, photosynthesis is the process by which green plants and certain other organisms transform light energy into chemical energy. Okay, so during photosynthesis in green plants, light energy is captured and used to convert water, carbon dioxide, and minerals into oxygen and energy-rich organic compounds. So energy produced by photosynthesis will be carried out by plants millions of years ago. Is responsible for the fossil fuels like coal, oil, and gas that power industrial society. Which means photosynthesis is very important for humans' life. Humans is so almost half of a century passed before the concept of chemical energy had developed sufficiently to permit the discovery, which is in 1845, that light energy from the sun is stored as chemical energy in products from during photosynthesis. So in chemical terms, photosynthesis is a light energized oxidation reduction process, which is redox. So in plant photosynthesis, the energy of light is used to drive the oxidation of water, producing oxygen gas and hydrogen ions and electrons. So most of the removed electrons and hydrogen ions will ultimately are transferred into carbon dioxide. Carbon dioxide which is reduced to organic products. So in most green cells, carbohydrates, especially starch and the sugar sucrose or glucose, are the major direct organic products of the photosynthesis. So which means we can conclude that photosynthesis is actually a process for plant to produce its own food. Okay, so the reactant, 6 carbon dioxide molecules and 6 water molecules. 6 water molecules are converted by light energy captured by chlorophyll in the plant, implied by the arrow, into a sugar molecule. And the products. So the sugar will be used by the organism and the oxygen is released as a byproduct, which then will be used by a human or another life being. So oxygen is the byproduct of photosynthesis and correspondingly carbon dioxide are the byproduct of respiration. Okay, we human undergoes respiration, so this is carbon dioxide. This is the product. So trees and forests are indeed our significant oxygen producers. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is SITI ZUBAIDAH binti MUHAMAD ZAFIR from Group 6. So today I'm going to talk about rusting and its prevention. So when iron or metal is exposed to oxygen and moisture, rusting will occur. So rusting describes the corrosion of iron and metal. So the term corrosion is used to describe the breakdown of metal when exposed to the environment. So when metal corrodes, it means that it has reacted with water and oxygen from the environment, forming their respective oxides. So the rusting of iron is characterized by the formation of a layer of a red, flaky substance that easily crumbles into a powder. So the exposure of iron or an alloy of iron to oxygen in the presence of moisture leads to the formation of rust. So this reaction is not instantaneous. It generally proceeds over a considerably large time frame. So the oxygen atoms bond with iron atoms, resulting in the formation of iron oxides. So this weakens the bonds within the iron atoms in the object or structure. So the reaction of the rusting of iron involves an increase in the oxidation state of iron, accompanied by a loss of electrons. Rust is mostly made up of two different oxides of iron that vary in the oxidation state of the iron atom. So these oxides are iron 2 oxide or ferrous oxide. So the oxidation state of iron in this compound is +2 and its chemical formula is ferrum oxide, FeO. So iron 3 oxide or ferric oxide is where the iron atom exhibits an oxidation state of +3. The chemical of this compound is Fe2O3. So what actually happened to rusted iron? So the iron has undergone oxidation reaction as follows. Atom of ferrum react with oxygen and also water, forming hydrated iron 3 oxide. So salt and acid act as catalysts for this reaction, which will result in the higher yield of rust on iron. So how to prevent rusting from occurring? So rusting can be very costly if you have to constantly replace these items made of iron and steel. So rust can be prevented if we clean the area exposed to oxygen and moisture. So this is done on many bicycles and cell. So the second method is adding a layer of oil or grease. So this is usually done on many bicycle chains. So by adding a layer of oil or grease, it will help to lubricate the moving parts, which reduces friction and slows down rusting process. So the third method is galvanizing. So we will have a look at the reactivity table below with magnesium, aluminium, zinc, ferrum, selenium, platinum and copper. These are all in decreasing reactivity. So as we can see, zinc is more reactive compared to iron. So when exposed to oxygen and moisture, zinc will corrode faster than iron. So if we put them together, the zinc will protect iron, but it is actually sacrificing itself. Hence, we use the term sacrificial protection. So this method is usually applied to prevent rusting on ships. So the oxidation of zinc can be described using this following equation. Zinc atom will react with oxygen, forming zinc oxide. So besides preventing rusting, there is another advantage to this galvanizing process, which is the formed zinc oxide layer can be removed and the freshly exposed zinc can corrode once again, which thereby further protecting the iron or steel hull from rusting. So that is all from me, thank you.
I share about the chemical reaction in digestion. What are chemical reaction? Chemical reaction are concerned with breaking of old bonds to create new bonds. It is the interaction of two or more substances resulting in chemical changes in them. The supply energy may be in the form of heat, light, or mechanical shaking for proper contact between the reactant molecules or electricity. While for chemical digestion it's broken down by digestive enzymes that convert it into smaller nutrients that your body can quickly absorb when food passes from your mouth into your digestive systems. This breakdown is called digestion of chemicals. For digestion and absorption is when large fat droplets enter small intestine after meal and bilious salts emulsify fats into smaller particles. Lipids break down fat into fatty acid and monoglycerides. Monoglycerides and fatty acids are absorbed through villi via micells and reform into triglycerides. And the nutrient will enter to the blood. Purpose of chemical digestion, there are four main products that being digest into our body, which is fat, nucleic acid, proteins, polysaccharides or carbohydrate sugar. Fat break down into fatty acids and monoglyceride. For nucleic acid break down into nucleotides. For protein it break down into amino acid. And lastly, for polysaccharide or carbohydrate sugar, it break down into monosaccharide. Where is chemical digestion begin? It begins from mouth, which is linguolipase. This enzyme breaks down the triglyceride, a kind of fat, and salivary amylase. This enzyme breaks down polysaccharide, a complex sugar that's a carbohydrate. There are four parts of chemical digestion follow, which is stomach, small intestine, large intestine, and the bottom line. Thank you for the attention that given for me and listening me well. Thank you.